As we had talked about, I'm David, the founder and CEO of Expensify, and we do expense reports that don't suck. It's a bold vision, but we're improving the world one expense report at a time. I'm not going to talk much about Expensify, but just so you have a vague sense of what we do, we're a service for business travelers. You take a picture of a receipt. We will read all the information off the receipt automatically, so there's no typing involved. We will submit it to your accountant. We'll get you fully reimbursed the very next day. So basically, when you're using Expensify, you put down your cash or coffee, you take a picture of the receipt, you put your phone away, you never think of it again, cash will be in your bank account tomorrow. And so we make that whole process easy. And so we're used by about 24,000 customers of all sizes. And so we have everything from, a million sort of like, or I guess 20,000 small businesses. And then of course, a bunch of big names you've heard of. There's Yahoo, there's like both Uber and Lyft use us. That's the only thing they can agree upon. Anything that starts with Zen uses us. All of the unicorns or former unicorns use us, things like this. And all of it is powered, actually, by this technology that we built internally called Bedrock. Now, I've been racking my mind to figure out how do you demo a database. Like, that's a really hard thing to talk about, especially because they always sound the same. Like, I'm looking at the start of our website here. I'm like, yeah, so Bedrock is, it's simple, it's modular, it's replicated, blah, blah, blah. And it's like, man, this sounds like every single database out there. It's like everything says the same thing. It always sounds like amazing. The challenge of databases is they break down in practice. And we saw this internally. So a funny thing is actually that story that Heather told about how I started is actually not true. It plays well, but the reality is I had no interest in expense reports when I started Expensify. I was doing something completely different. I was doing a prepaid debit card company. And actually, I wasn't even going to deploy to the internet. The network I was targeting was the ISO 8583 network. It's a TCP/IP network. It's like a private internet for the banks. And in order to get onto it, you need to satisfy the banks. And the banks are like, okay, we're not going to put your technology onto our network unless it's incredibly fast. It's like millisecond response times it has to have. And it also has to be an active-active configuration. It has to be super redundant. And basically in all of this. And so it's like basically the only people on this network were like giant companies. And I'm just like, me. And I'm like, okay, I need to find a way to meet their really intense availability and performance requirements on day one before I can even launch. And so I built this technology. So I looked at what's out there. Like I have a lot of experience with MySQL. Everyone does. And it just sucks in many ways. It's like, don't get me wrong, MySQL is used powerful, like probably like 2/3 of the internet use MySQL. But they've been using it for a long time. MySQL was built for a different era, literally a different century. And I think that things have changed over the past, 100 years since the start of the internet. And I would say, first, we don't use spinning disks anymore. And so all the optimizations and weird trickery they had to have for spinning disks doesn't matter. Cache coherency is a very different world today than it was then. It's like, we don't have 4 GB volumes anymore. You don't have to like span and join all these weird sort of like different volumes together. We just have giant SSD RAID drives. And they're so freaking cheap. Like I just checked for fun, the cheapest server you can buy on Dell, like the absolute cheapest server, comes with like a 500 GB hard drive and RAID, and out of the box. Like you can't not get this much. And that costs like $700. And if you upgrade to like, just max out their cheapest platform to the max, it's like $3,000, and you have like, I think it's like 3 terabytes or something like this. It's a lot of data, more data than actually most startups will ever need. And so this is like the cheapest stuff here. So the world has changed since the start of databases, but the databases haven't really changed along with it. And that's why when we started, we said, okay, my background's in peer-to-peer technology, and so I'm like, I can build a distributed transaction engine, no problem. So let me try to talk about like in a bit more detail why it's different. And I'd say Bedrock is faster. It's faster because actually Bedrock is actually a layer on top of SQLite. SQLite is actually the most widely used database in the world because it's used in your phone. And almost no one thinks about it because it has no networking layer. And so people disregard it. SQLite is freaking amazing because it operates actually in the memory space of your application. You have direct RAM access to the database. Nothing can possibly be faster than SQLite. There's no serialization of our network, any of that garbage. It's just incredibly fast. It's so simple. SQLite is just a single file in your file system. Like you can't get simpler than that. It's incredibly reliable because there's nothing to crash, but also because our layer on top of it allows you to configure an active replication environment across data centers, which is actually very hard to do. And it's also more powerful because SQLite actually is an incredibly feature-rich engine. And so therefore, it's not just about SQL. It's also about JSON. It's about triggers. It's about everything you could possibly imagine. And so still I'm trying to think how do I convey just how simple, like I'm sure you've heard all this before and it's like, yeah, whatever, doesn't really matter because everyone says the same thing. And so I want to convey just how simple it is here. I'm going to talk about how simple it is to install. It's basically, it's apt gettable like anything else. And so we go here, I've got some sort of vagrant environment. And so I'm installing Bedrock here. And the way it works is, basically you connect to it over a socket. It's like the most basic thing. The protocol is so basic that the primary way I like to interact with Bedrock is actually over Netcat. It's basically like a more simple version of Telnet. It's like you can't get any simpler than this. And so it's like, okay, let's go Netcat, localhost, because listening to there. And so now I'm talking to it. Amazing. So it's like query, run a query. It's like select, 1. And amazing. So we just got the results back. So it's like, right there, it looks like, I know you're like thinking like, what did I just see? Is that even anything interesting? What you saw was you installed an incredibly powerful multi-data center replicatable database and you're connected to it over side, and it looks so boring. The fact that it looks boring is amazing because it means all the bullshit you don't have to deal with. Like other places, they're like, yeah, we get this dashboard, this thing, you install this Ruby, blah, 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 all this junk. It's like, you don't need any of that garbage when you use Bedrock. You just use the basics. And so we talk about, it's like, okay, it's full on, SQL, so you can do whatever you want, no problem. You can also, if you're a robot and you actually don't want to see sort of like human formatted data, that's cool. It'll output JSON for you. And likewise, because some people just freaking love their tools. I know they do. I don't know why, but I just know they do. If you really love MySQL and you really love the MySQL command line, that's cool. We just made it support it. And so basically, Bedrock actually supports the MySQL protocol itself. So again, if you just want to access MySQL, so you can see here, we've connected to it. It says the version of MySQL is Bedrock. And so again, of course, you can run the same SQL commands you run from anywhere else, except now you can run the MySQL thing. So it supports MySQL. That means it supports your clients. It supports your client libraries, whatever weird binding you want to use. That's cool. Support that. Or you can actually just do the simple way. And we actually have a very basic PHP library that looks something like this. Basically, you just connect to Bedrock, execute a query. So basic, so simple. It really can be that easy. So I'm trying to talk about, it's like, okay, but still, I don't know if I've really conveyed just how powerful this is. And so I'm going to talk about Bedrock is more than just a database. It's a whole platform for your application. Because like really, if you're doing something in the back end, you're not just doing data. You also might want to do like job queuing and caching, things like this. And normally they force you to use these entirely different solutions. They'll tell you, it's like, oh, of course you can't use a database for this stuff. You have to use a job queue, whatever it is. That's bullshit. Because really, it's all data. And whatever sort of job queuing system you use probably sucks because it actually doesn't use a real data engine, so therefore doesn't have any sort of ACID transactions, so if it crashes in the wrong way, your whole job queue gets screwed. It probably doesn't have real replication, so therefore if one of its master dies, it has some sort of janky-ass system that fails over. It's probably garbage, but it's the best that's out there, and that's why you use it. This is actually a much simpler and more powerful system. So for example, let me talk about our job queuing system. And so the way it works is, it's like very simple. Let's say you want to queue a job. Let's say you want to create an application that is every minute you want something to like check some sort of liveness of a website. So it's like, okay, cool. Let me go back here. I'm going to create a job. And it's like, great, I've created a job. It's job number 1. It's like, okay, so you've had one system that created a job in the job queuing system. Now we have something else that's like some sort of worker bee that's basically trying to get jobs to run. So it's like, okay, give me a job. And it's like, cool. There's one job called get liveness. And you can see it's like, here's the data describing what that job does. No problem. And so you can actually say, awesome, I'm in the process of updating this job or running this job. I can communicate, like update this job queue such that other systems can get status on it. Like maybe you've got like an Isinga dashboard that's showing you what jobs are running and things like that. No problem. All this stuff is super easy. And so, of course, systems can query the job, whatever. And then, of course, when you're finally done with the job, and let's say in this particular case that maybe you wanted to communicate that actually this check failed. You want to record the fact that it failed somewhere. Just record it in the job itself, just so the next time it runs, it has the status of the last time it ran. So recall that I made this job, and I gave it a name and all this stuff, but right now it's we configured it to run every minute. So I said, get job right now. You can see it says there's no job available. It's because the job just ran less than a minute ago. So it's actually waiting before I can run it again. But this is why it's great if you want to see how it works, because Bedrock is just a database. Under the hood, if you want to see all the jobs there, cool, you can check the jobs. You don't, again, look some sort of weird dashboard or things like this. Just use SQL. You know it, you love it. And then eventually it's like, okay, what is query select? Okay, so it's currently queued to go in 22:28, so maybe another 20 seconds you'll see. Okay, there we go. There's a job. So you can see basically a recurring basis. I scheduled something to happen every minute, which is actually, it's like, that sounds like that's not hard. But I didn't use cron. I didn't use any garbage to actually make this thing happen. It's very simple. It's actually a reliable system that scales across different data centers. And so likewise, and as I'm thinking, it's like, okay, so you have to have some sort of like worker that's polling the system. No, polling sucks. Instead, what you actually have is you have a worker can actually just do like a timeout. Say like, hey, I want to wait for the send email job, and I want to wait up to 60 seconds. You see, it hasn't responded yet. So I'm going to go over here in this incredibly small window and say connect again, localhost. And so it's like, okay, so we have one server working, waiting for work to happen, but it's not polling. It's actually very efficient. So we have some other basically process that's going to create a job, and you can see when I send it, basically it woke up the worker. So basically without any sort of polling, the worker has responded instantly. This means that there's no very high performance, very low overhead job queuing system. So again, job queuing, database, everyone sort of knows what this are, but it actually is very hard. You have to use a wide series of tools to make this happen if you're going to use others. And so with the Bedrock, you actually get all the basics sort of right out of the gate. And the third, maybe I was talking about, is we also have a basic caching layer as well. And our caching layer is basically a replicated cache. So let's say you want to query something from the database, and it's very expensive to get, and so you want to hold on to the results such that you can query them again. Basically, you can just throw them into a cache, and so we've got all that for you. So in a nutshell, that's kind of what Bedrock is. Bedrock is not just a database, it's also a job queue, it's a caching layer, but more importantly, it's a foundation for your entire online service. And it's a foundation that scales to global scale applications. And so when I go back to like what makes Bedrock special, I think that there's a few things under the hood that are not entirely obvious from this 30-second demo that I just gave. One of those is it's incredibly reliable across multiple data centers. So for example, let's see if I can do this one here. Stop. Okay, so we're going to kill Bedrock here. What I've done is I've actually configured basically the idea of mapped 3 different nodes to my Etsy host, so basically all go to localhost. I'm going to simulate running 3 different basically versions of, here we go. I'm going to configure basically a 3-node configuration of Bedrock on the same server. So I'm going to run these 3 guys here. So now I'm running basically 3 copies of Bedrock locally. And so you can't really tell because there's nothing to see, but if I go to Netcat localhost 8000, let's say, you can see that this one is basically like responding like, hi, I'm node 0. This one here says it's node 1. So we've got multiple servers operating basically in the same system. And you can see this one here, if you dig deep into the JSON, it says that the node 0 is mastering, node 1 is slaving somewhere in here, in this big mass here down. And so the idea that we have actually multiple nodes, they're synchronizing automatically. And like, do you think that you could configure a SQL Server in a replicated environment that fast? I highly doubt it. Because you'd have to use all these funky tools and all sort of junk. No, this is actually very simple. Everything's command line oriented. It doesn't need to be complicated because the complexity of all these systems come from all the garbage that's been accumulated over years of supporting basically like, hey, how exactly do you want to like sort of file system coherency and all this sort of stuff? You don't need any of that more. Just a one single giant file on disk. And because it's a single giant file on disk, it's very basic to back up. It's easy to administer. And so now you can also see it's like, so now I'm connected to node 1 here. I'm going to say, query, create table, blah, foo. And it's like, awesome, query, insert into blah. Oh, I wish I could type faster. There's one. Okay, cool. So now I've exported basically created a table automatically, and what you didn't see there is it's actually been replicated to those other nodes. And so if I go and kill one of those other 3, everything already has it automatically because it uses distributed transactions across these different nodes. And maybe I'll finish on a final point, and that is Expensify Bedrock is designed to be replicated across multiple availability zones in different data centers, which doesn't really make sense until you recognize the differences there. I'd say most databases are configured for an active-passive configuration with manual failover inside the span of a single data center. Expensify, however, is designed for active-active, meaning that all your servers are always active, and furthermore, it can be distributed between multiple data centers over a very slow, unreliable internet connection, such that different data centers will frequently lose connectivity to each other for like 5, 10 seconds, whatever. Bedrock doesn't care. MySQL, SQL Server would freak its shit out. And so basically, it is just hardened against the real world and designed to operate super high performance, distributed active-active configurations, unlike any of the database out there. Thank you.